Alright, so now let's look at the exercise for forces on the current element with an external magnetic field. Okay, this one is page 154. Okay, so we look at the questions number 1. Right, so now you have a conductor, okay, carries a current, okay, that is the 70 ampere I at right angle. Okay, what's the meaning of right angle? Means that, okay, now, okay, the directions of the current element is having a angle of 90 degree to a magnetic field. Okay, magnetic flux density B 1.5 Tesla. Okay, so it means that if this is your I directions, okay, your B directions, okay, will be, you will have a 90 degrees angle, right? This is the meaning. If the length of the conductor in the field is 200 millimeter, okay, this is the length. Calculate the force acting on the conductor. Okay, so here is one question. Calculate the force. And what is the force again? Okay, well, now the angle is 45 degree. Okay, so you have two questions to solve in these single questions. Okay, so now is talking about a conductor that has a current. What is the force, right? So you have to use the correct equations, which is this one. Okay, so IDL and cross with the B. And cross with the B. Okay, so we know what is the value of the I, that is a 70. Okay, 70. And we have no idea actually. We have no idea what is the where this I locates. Am I right? Okay, we have no ideas. Okay, so maybe I can just assume it. I can assume. Okay, I can assume, for example, I assume this I is in the y directions. Okay, I assume this one is, I assume myself, right? Dy y directions. And the B, okay, B is 790 degrees of angle difference. Okay, with the I, so I assume my B is the x directions. Okay, so 1.5 x directions. Okay, so the length I'm reporting it as from 0 to 200 millimeter, so it's 0.2. Okay, you have to convert it to meter. Convert it to meter. Okay, so now it will be 70 multiply with 0.2 and multiply with 1.5. Okay, so y-x you get negative z. Yeah, negative z. Okay, so it is 70 times 0.2 times 1.5. Okay, so it is 21 is the magnitude and the direction is negative z. And of course, if you assume different directions for this, you will get different direction of force, because this question doesn't specify about what is the directions, right? So we can put any directions. Okay, as you can see, they only want the value. Okay, so as long as your value is correct, then it is acceptable, right? Okay, so if you don't wish to put the directions, okay, you can use the concept of sine theta, right? Remember, for the cross product, it will be sine theta, right? So you can rewrite this to be integrate I. So the dl cross the b, right? So it will be equals to integrate 0 to 0.2 I. Okay, you can put dl. You can put dl. Okay, dl, and multiply the magnitude of dl. Okay, multiply with the b, and also the angles difference between terms. Okay, which is sine 90, and then this one. Okay, so if you don't want to consider the directions, you can just cancel this thing. So this one will give you 70 same thing. multiply 0.2 and multiply 1.5 and sine 90. Okay, you will get the same answer, which is also 21 Newton. Right? Okay, so this is the first part of these questions. So you have a second part. Okay, when they mention the angle difference between the I and the B become 45 degree. 45 degrees. So you can actually use back this formula. Right. Use back this formula. Right. So the F now, okay, because we only talk about the magnitude. Okay. So it could be 70 multiply with 0.2 multiply with 1.5. Okay, the same thing, right? But now the sine 90 you replace with a sine 45. Okay, sine 45. Sine 45. So it's 14.85. Okay, Newton. Is it correct? 14.8, something like that. Okay, so this one will be the force. Okay, we look at the next questions. Questions number 2. Question number 2. Question number 2. Right, so this is your questions number 2. So calculate the current required. Okay, now you need to find what is your I. In a 240 millimeter length of the conductor of a DC motor, when the conductor is situated at right angle to the magnetic field flux density of the B. So if a force, okay, the force is to be exerted on the conductor. Okay, so in this question, again, they didn't give us about the exact direction, right? They just mentioned about right angles. Okay, the force is given, so we can directly apply this formula. The I, okay, multiply with the L, multiply with the B, and sine theta. Okay, where this thing from? Okay, this thing is from here, right? So you have the I, right? You have the I, and you have the L, you have the B, you have the sine theta, right? Exactly from here, because in this case we don't really care about the directions, okay? The directions, okay? Right, so you can just put them into the correct positions, right? I is, you don't know, so it's 0.24, okay? And the B is 1.25. And the sine 90, yeah, okay, is a right angle, so sine 90. Okay, so your I will be, let's divide 1.2 divide 0.24, so you get a 4. Okay, 4 ampere. Okay, 4 ampere. We look at the question number 3. Okay, question number 3, yeah. Okay, so now you have a conductor of 30 centimeter length. Alright, this is the length. Okay, situated at a right angle again to a magnetic field. Calculate the B. Okay, so I is given. Okay, the F is also given. Okay, quite similar to the previous questions. Okay, so I will use this formula. I multiply with the L, okay, with the B, and with the sine theta. Okay, so put the force as 3.6, the I is 15, the L is 30 centimeter, 0.3 meter, and the B you have no idea, and sine 90. So your B will be 3.6 divide 15 multiply 0.3. Okay, so you get 0.8 Tesla. Alright, okay, it's very easy. Alright, we look at the exercise for forces between two current elements. Okay, so you have three infinite lines. Okay, infinite lines, so infinite lines. Okay, so L1, L2 and L3. Okay, so they are defined by L equals to 0, Y equals to 0. Now this is L1. Okay, this is L1. And for the L2 is defined by this one, L2. And the L3 is this one. Okay, L3. So this is their current, I1, I2 and I3. Okay, in the Z directions. Find the force per unit length. Okay, so you are required to find the force per unit length. Okay, on L2 due to L1. Okay, and so on. Okay, so we look at the A. Question A. L2 due to L1. Meaning that you want to find the force that is acting on the L2. Okay, because of the L1. Okay, so L1 has the I1. Okay, so this will give you the equations for I2 here. Okay, because this is the force acting on the L2. So you have I2, so dL. And L1 has I1. And this I1 produce B1. Okay, will produce the B1. Okay, so this one will be your equations. Okay, so you can put it. So for the I2 is equals to 200. Okay, 200. Okay, so all of them. Okay, right. I think I haven't drawn. I haven't drawn yet. I haven't drawn yet that length. So let's draw it. In the 3D diagram over here. Okay, so for the L1, X is 0, Y is 0. X is 0, Y is 0, meaning that your L1 is this. Okay, so this one is your L1. Okay, so all the point along the L1, okay, their X is 0, Y is equals to 0. That's why it is labeled as the L1. Okay, we go to the L2. L2 is X0. X is 0, Y equals to 4. Okay, X0, Y equals to 4. This one will be another one. Okay, which is this one. So all the point here, they have their X0 and the Y is equals to 4. Okay, Y equals to 4 here. Okay, so you have one more, that is the X equals to 3, Y equals to 4. X equals to 3, Y equals to 4 would be over here. So 3 is here, right? 4 is here. So this one will be the positions. Okay, so your line will be this. Right, you're clear about these L1, L2 and L3. L3. Okay, so currents. Okay, current for the I1. I1 is negative. Negative 100 Z. Meaning that is going down. Right, 100. Okay, L2 is 200. Okay, so it's 200. And L3 is 300. In the Z directions. Okay, so for this one, we look at I2. okay, I2 is here, the blue one, okay, so the length, okay, is in the z directions, okay, so you write it, the length is a dz, z directions, okay, and the length is from, okay, we will say that from negative L to L, okay, is the length, okay, negative L to L, or this is the negative L, okay, infinity, yeah, negative L to L, okay, right, cross product with the B. B is the magnetic flux density that is generated by the I1, so you will have a mu naught I1 over 2 pi R and V. Okay, so this one is the equation of your B1. You could replace the I1 with 100. Okay, just replace the value 100. As for the R, okay, for the R, you can calculate it. Right, how to calculate it? Okay, so you want to find the magnetic field at the positions of I2. Okay, at the position of I2 here. So this is the point that you want to find the magnetic field. Okay, so how to find the R? Okay, so the R will be the distance between the L1 and also the L2, which is 4 units, right? So the R equals to 4 units. And the directions will be, okay, look at here. Okay, so from the I1, okay, towards the I2, let me draw it. So your direction of your R will be in the Y directions. Okay, maybe the Y directions. Okay, if you are not sure how to use this method, right, you can also use the method as in your module. Okay, finding the point T first. Alright, we always start with the point T, right? So in this case, okay, the point T will be along, okay, along the line I1, L1. So the point T will be 0, 0, and Z. Okay, you have no idea what is the Z, yeah? Okay, as for the observation point, the point T, the point P, yeah, it is at position x equals to 0, y equals to 4, and the Z you have no idea also. Okay, so your R, okay, you can find it by P minus T. 0, 4, Z minus 0, 0, Z. So you will have a 0, 4, 0. This is a distance vector. So your distance is equals to 4, and the unit vector R will be 4 over 4, so which is Y. Okay, so this is how you determine the value of the R and also the directions. Okay, so we can now put it here. So the R you could replace with 4. Replace with 4. And the d phi equals to the direction of the I1, which is a negative Z. Cross product with the unit vector R, which is Y. Yeah, take note of this. Okay. Now, let's do it. Try to calculate. So here you have 200 multiply L minus negative L, okay, multiply with 5 micro. Okay, so zy, okay, zy you get negative x. Okay, this one will give you the negative x, negative, positive. This one give you positive x. This one give you positive x. Okay, so zx you get y. Okay, zx you get y. So it is equals to 1 milli L plus L. Okay, in the y directions. So L plus L, okay, is, we call it as a length, right? This is the length. So the F2 divide length would be 1 milli, okay, y directions, Newton per meter. Okay, so this is the first answer. X directions, L2 milli. Y is X direction. Let me double check. This is negative Z. I think this is correct, right? X, Y, Y is this one, Z, Y, X, X, Z, Y. I think should be correct. Okay, Y directions. So this one, the answer should be Y directions. Let me correct it. This one. It should be Y directions. Okay, so it's wrong. Okay, we go to the second questions. L2, L1 due to L2. So what is this? You want to find the force per unit length on the L2. So meaning that you want to find the F1. L1. Okay, due to L2. Okay, so this one is your length. This is what you want to find for question number B. Question number B, you want to find the force acting on L1, okay, so which is the F1 due to L2. So this L2 you have the I2 lah, right? Okay, so what is the equations? I write down the equation first. Okay, F1 equals to the force acting on I1, because of the magnetic field, okay, due to the B2. B2 is the I2 lah. Due to I2, so it produces the B2. Okay, so we look again the drawing. Okay, so this is the drawing. Copy again. I'll put it here. Okay, this is a drawing. So let me correct this one. Okay, so let's write down the equations and value. If we know the value, we write down the value. So I1 is 100, okay, and the DL is the DZ. Cross product with the B2. B2 is produced by I2. Okay, so 2 pi R and V. Okay, so this is the equation, sir. So this is the equations. Okay, so the length, okay, the length of the I1 okay, the length of the I1, you see, it is from, okay, L to negative L. Follow the direction of the current, L to negative L. Okay, now it is the R over here. So how to find the R over here? So first of all, let's sign the T first. Okay, so for the I2, I2 is this one, I2, this is the I2. So the T would be 0, the Y is 4, and the Z you have no idea. And the observation point, okay, is at the position of I1. I1, So I1 position is 0, 0, Z. Okay, so your R will be 0, 0, Z minus 0, 4, Z. Okay, so you will have 0, negative 4, and 0. So R will be 4. Okay, unit vector R will be negative Y. Okay, negative Y. Okay, so you can put it inside L, negative L. Okay, so we have 100 dz and z. Cross product mu naught. Okay, my I2 is equals to 200 over 2 pi r. R is equals to 4, and the direction of your current I2 is positive z directions. Cross product with the negative y, unit vector r. So now you can calculate it. So you have okay, so this is 1 milli. 1 milli multiply negative L minus L. Okay, so this ZY, okay, ZY give you negative X. Negative, negative become positive X. So Zx equals to positive Y. Okay, Zx equals to positive Y. This is your F1, right? So if F1 divide with the length, okay, what is length? Okay, negative length. This is negative length, right? So you will have a negative 1 milli in the y direction, Newton per meter. Okay. Wait, okay. Now we go to the next one, question C. What question C1? L3 due to L1. Now find the force on L3 due to L1. Okay. L3 due to L1. Okay, so now we want to find the force acting on L3. Okay, due to L1. Okay, so this one will be 3. Find the force acting on L3, which is I3. Okay, because of the magnetic field produced by I1. I1 produces B1. Right. Okay. This one try to take again. Okay, so we take again this drawing. Copy. Okay, so this is the equations. And this is a drawing. Okay. Let me draw it. Let me move it a bit. Okay. So put the value that we have. What is I3? So I3 is 300. dz and z. Cross product with the B1. So B1 is produced by I1. Right. And for the I3, okay, it is from negative L to L. Okay. Now calculate this R. Okay. You want to find the magnetic field that is produced by the I1 at the positions of L3. Okay. So your T, okay, will be along the L1, the I1. So it is 0, 0, Z. Okay, and your observation point is the L3, okay, which is 3, 4, and Z. So your R, okay, will be minus, okay, P minus T. So it will be 3, 4, 0. Okay, so the magnitude will be 9 plus 16, which is square root 25 equals to 5. And the unit vector R is 3, 4, 0 over 5. Okay, now you put it here equals to integrate negative L 300 dz and z multiply mu naught I1 is 100 over 2 pi 5. The directions of the I1 is in the downward direction, negative z. Okay, and cross product with 3x plus 4y over 5. Okay, so here we have to settle first the things. Let's multiply together first. So we have so we have a 7.2 first. This represents the first part there. Then we have second part, which is 9.6 times 10 power negative 4. Okay, so for this, zx will give you y. Okay, so it's negative y. So zy will give you negative x, negative, negative, positive. Right. So now, next term is this, z and this y. Okay, z and this y. Z and the y here. So zy, negative x, negative, negative become positive x. Okay, and next is z with this. Zx, you get positive y. Okay, positive y. Okay, right, we have to multiply also, and we haven't multiplied this one. L plus L, this is the length. Okay, So meaning that your F3 over the length is equals to 7.2 x directions plus 9.6 y directions Newton per meter. Okay, so this is a positive length. Huh? Okay. Now we go to the next questions. Okay, force acting on the L3 due to L1 and L2. Okay, so force acting on the L3 due to L1 and L2. This one you have to add the force together. Okay, so meaning that you have to find the F3, okay, due to the L1, okay, which is the question C, okay, plus the F3, yeah, due to the L2. Okay, we can use the answer here in C, but for the D, we need to calculate what is the F3 due to L2. Okay. So we go to question D. Yeah. F3 due to L2. Due to I2 lah maksudnya. Okay. So F3 is equals to the force acting on the I3 due to the magnetic field of I2. Okay, so our I3 is I3. Take this one again. Okay, so what is I3? So the I3 is 300. This is I2 and V. So the current is flowing from negative L to L. Okay. Okay. So now let's find the R. Okay, so first of all, we find the point T first. Okay, the point T would be on the I2. I2. So I2 is 0, 4, Z. And the observation point will be point on the L3, okay, which is 3, 4, and Z. So the R will be P minus T, okay, so it's 3, 0, 0. So equals to 3. Then this one will be equals to X. Okay, so put the value negative L to L, 300 dz z cross mu naught. Okay, and this is I2. So I2 is 200 over 2 pi. R is 3. Okay, so the DL for the I2 is in the positive Z directions. And cross product with the R. Okay. So let's calculate. So we have a 4 milli, and this is L plus L. Okay, so ZS you get negative y. No, positive y. Zx, positive y. Okay, zy, negative x. Okay, so this is your f3. So f3 over length, so it would be negative 4 milli x Newton per meter. Okay, so add them together. Okay, add them together. Now the F total acting on the L3 or the I3 will be the summations of this together with the answer just now, this. Okay, add them together. So you will get your answer equals to negative 3.28. Okay, milli, yeah. Plus 9.6. Why, if you write to be, you want to combine it to be milli, yeah. 9.6 will be 0.96 y milli Newton per meter. Okay, so this is the answer. Okay, now we look at the second question, sir. Okay, so it is given two infinite wire. Okay, two wires, two. Okay, separated by a distance of 75 centimeter. The current flow in this wire are 2 ampere and 0 ampere respectively. Okay, so you understand the questions. Maybe let's try to draw it. Okay, so this question doesn't really tell us what is the positions of the wire. So it's okay, we just draw it. Okay, just draw it. Okay, we just assume the first wire is here. Okay, and then the second wire is 75 centimeters away. Okay, so this is 75 centimeter. Okay, they didn't tell us also the current. Never mind, we assume it to be 2 ampere. And this one, the current is 0. The current is 0. What is the force on these two lines? Okay, what they want? They ask you to find the force, okay, due to I1, and they want you to find the force due to I2. If this is your I1, if this is your I2, what will be the equations? So for the F1, okay, this is the force acting on the I1 due to the magnetic field that is generated by the I2. Okay, so in order to generate, okay, the magnetic field, okay, you must have the I2. Am I right? Look at this case. Do you have an I2? You don't have the I2. The I2 is 0. So showing us that all these things will turn to be 0. There is no force acting on the I1. Am I right? You see the reason why? Why the F1 is 0. Right. We look at the F2. The F2. What is the equation for the F2? F2 is the force that is acting on the I2 due to the magnetic field that is generated by the I1. So do you have anything, do you have value for the I2? I2 is what? I2 is 0, right? I2 is 0. Even though you have the B1, right? But this 0 is going to map the F2 to be 0. Okay, so you see what is the answer. So there is no force between these two lines. Okay, because the current I2 is 0. This is the reason.